Article 700 addresses emergency systems. The permissible loads on emergency systems, as well as essential electrical systems described in Article 701, legally required standby systems, detailed in Article 702, and optional standby systems, outlined in Article 703, are important considerations. The term legally required, within the context of emergency systems, typically refers to systems mandated by law or regulation, intended to ensure the safety of occupants and property. Examples of legally required systems include fire, alarm, and emergency evacuation systems, elevator emergency lighting and control systems, exit lighting and emergency signage, and emergency communication systems. Regarding whether a backup freezer used for research qualifies as a legally required load, a determination depends on the specific requirements and regulations applicable to the particular facility. Several factors must be taken into account in making the determination. Firstly, consider the type of research being conducted. If the research involves materials or substances that could pose a hazard to personnel or the environment should a power outage occur, then a backup freezer might be legally required. Secondly, assess regulatory compliance. The facility might be subject to regulations emanating from federal, state, or local authorities that mandate the employment of backup systems for essential equipment. Thirdly, analyze institutional policy. The university itself may have its own internal policies that compel the use of backup systems for certain categories of equipment. In general, if the research being conducted at the facility involves materials or equipment that could be harmful if not properly stored during a power outage, it is prudent to consider providing a backup system for the freezer. This consideration is heightened if the freezer contains materials that cannot be easily replaced or if the research is time-sensitive. It is advisable to consult with legal counsel to definitively determine whether the backup freezer qualifies as a legally required load under applicable laws and regulations. When designing or evaluating an emergency system, adherence to the National Electrical Code, particularly Article 700 and related articles, is crucial for ensuring compliance and safety. Understanding the specific requirements for legally required standby systems as defined by the applicable codes and regulations is critical. The NEC provides detailed guidance on the installation, wiring, and maintenance of emergency systems to ensure they function reliably when normal power is interrupted. Emergency systems are intended to automatically supply illumination, power, or both, to designated areas and equipment in the event of failure of the normal supply. These systems are essential for life safety and property protection. The scope of legally required standby systems extends beyond just emergency lighting to include equipment necessary for maintaining essential operations during power outages. This can include ventilation systems, critical process equipment, and communication systems. Regular testing and maintenance of emergency systems are vital to ensure their operational readiness. The NEC mandates periodic testing and inspection to verify that the systems are functioning correctly and that all components are in good working order. Documentation of testing and maintenance activities is also essential for demonstrating compliance with regulatory requirements. It is important to coordinate with local authorities having jurisdiction to ensure that the design and installation of emergency systems meet all applicable codes and standards. AHA may have specific requirements or interpretations of the NEC that must be followed. When evaluating whether a specific load, such as a research freezer, is considered legally required, it is necessary to consider the potential consequences of power loss. If the loss of power could result in a hazard to personnel, damage to property, or a violation of regulatory requirements, then the load should be considered essential and provided with backup power. In the context of research facilities, the nature of the research being conducted is a key factor in determining the need for backup power. Research involving hazardous materials, critical experiments, or time-sensitive processes may require uninterrupted power to ensure the safety of personnel and the integrity of the research. The NEC provides guidance on the types of loads that are permitted to be connected to emergency systems. In general, only loads that are essential for life safety, fire protection, or critical operations are allowed to be connected to these systems. Non-essential loads should be connected to optional standby systems or load-shedding systems to prevent overloading the emergency power source. The selection of the appropriate emergency power source is also a critical consideration. Emergency power sources can include generators, batteries, or uninterruptible power supplies, UPS. The choice of power source depends on the size and type of load, the required runtime, and the reliability requirements. Generators are commonly used for larger emergency systems that require long runtimes, while batteries and UPS systems are used for smaller systems that require shorter runtimes. The transfer of power from the normal source to the emergency source must be seamless and reliable. Automatic transfer switches (ATS) are used to automatically switch to the emergency power source when the normal power fails. ATS must be properly sized and maintained to ensure reliable operation. In addition to the NEC, other codes and standards may apply to emergency systems, such as the National Fire Protection Association, NFPA 101 Life Safety Code, and NFPA 110 Standard for Emergency and Standby Power Systems. These codes provide additional requirements for the design, installation, and maintenance of emergency systems. It is important to stay up to date with the latest editions of these codes and standards to ensure compliance. Emergency systems are a critical component of any facility, and proper design, installation, and maintenance are essential for ensuring the safety of occupants and the protection of property. Understanding the NEC requirements for emergency systems is vital for electrical engineers, contractors, and facility managers. When considering legally required standby systems, it is necessary to define the scope of the system based on applicable codes, standards, and regulations. The definition should clearly identify the specific loads that are required to be backed up and the required runtime for the system. It is also important to consider the potential for future expansion of the system and to design the system to accommodate future needs. Legally required standby systems must be designed to operate independently of the normal power source. This typically involves the use of a separate power source, such as a generator or battery system, and an automatic transfer switch (ATS) to switch to the standby power source when the normal power fails. The standby power source must be sized to accommodate all of the loads that are required to be backed up, with sufficient capacity for future expansion. The installation of legally required standby systems must comply with all applicable codes and standards, including the NEC, NFPA 110, and any local codes or regulations. The installation must be performed by qualified personnel and must be inspected and approved by the authority having jurisdiction. Regular testing and maintenance are essential for ensuring the reliability of legally required standby systems. The system should be tested periodically to verify that they are functioning correctly and that all components are in good working order. Maintenance should be performed on a regular basis to prevent failures and to ensure that the systems are ready to operate where needed. Documentation of testing and maintenance activities is essential for demonstrating compliance with regulatory requirements. The documentation should include the date of the test or maintenance, the results of the test, and any corrective actions taken. Legally required standby systems are a critical component of many facilities, and proper design, installation, and maintenance are essential for ensuring the safety of occupants and the protection of property. Understanding the applicable codes, standards, and regulations is vital for electrical engineers, contractors, and facility managers. The specific requirements for legally required standby systems can vary depending on the type of facility and the applicable codes and regulations. It is important to consult with the authority having jurisdiction to determine the specific requirements for a particular project. In addition to the technical requirements for legally required standby systems, there are also administrative requirements that must be met. These requirements can include obtaining permits, submitting plans for review, and undergoing inspections. It is important to be familiar with the administrative requirements and to ensure that they are met in a timely manner. Legally required standby systems are an important investment in the safety and reliability of a facility. By following the applicable codes, standards, and regulations, and by working with qualified professionals, it is possible to design, install, and maintain systems that will provide reliable backup power when needed. Considering the specific example of a backup freezer for research, the determination of whether it qualifies as a legally required load hinges on a comprehensive assessment of several factors. These factors include the nature of the research being conducted, the potential hazards associated with the materials stored in the freezer, and any applicable regulatory requirements. If the research involves hazardous materials such as infectious agents, radioactive substances, or highly reactive chemicals, the loss of power to the freezer could pose a significant risk to personnel and the environment. In such cases, a backup power system for the freezer would likely be considered a legally required load. Even if the materials stored in the freezer are not inherently hazardous, the loss of power could still have significant consequences. For example, if the freezer contains irreplaceable samples or critical research data, the loss of power could result in the loss of valuable resources and the disruption of ongoing research projects. In such cases, a backup power system for the freezer may be considered necessary to protect the integrity of the research. The regulatory requirements applicable to the facility are also a key factor in determining whether a backup power system for the freezer is legally required. Federal, state, or local regulations may mandate the use of backup power systems for certain types of equipment or facilities. For example, healthcare facilities are typically required to have backup power systems for critical equipment, such as refrigerators used to store vaccines and medications. Even if there are no specific regulatory requirements mandating the use of backup power for the freezer, the facility may still have a legal obligation to provide a safe and healthy environment for its employees and visitors. This obligation could extend to providing backup power for equipment that is essential for maintaining a safer and healthy environment, such as a freezer used to store hazardous materials. In addition to legal requirements, institutional policies may also play a role in determining the need for backup power for the freezer. The university or research institution may have its own internal policies requiring the use of backup power systems for certain types of equipment. These policies may be based on risk assessments, best practices, or other factors. When evaluating the need for backup power for a research freezer, it is important to consider all of the relevant factors, including the nature of the research, the potential hazards associated with the materials stored in the freezer, applicable regulatory requirements, and institutional policies. A thorough risk assessment should be conducted to determine the potential consequences of power loss and to identify the appropriate level of backup power protection. The risk assessment should consider factors such as the type of materials stored in the freezer, the sensitivity of the materials to temperature changes, the time required to restore power, and the availability of alternative storage options. Based on the results of the risk assessment, a decision can be made regarding the need for backup power and the appropriate type of backup power system. The backup power system should be designed to provide reliable power to the freezer in the event of a power outage. The system should be sized to meet the power requirements of the freezer and should have sufficient runtime to cover the expected duration of power outages. The backup power system should also be regularly tested and maintained to ensure that it is in good working order. In summary, the determination of whether a backup freezer for research qualifies as a legally required load depends on a comprehensive assessment of several factors. These factors include the nature of the research, the potential hazards associated with the material stored in the freezer, applicable regulatory requirements, and institutional policies. A thorough risk assessment should be conducted to determine the potential consequences of power loss and to identify the appropriate level of backup power protection.